In 2016, researchers examined a Greenland shark caught in cold Arctic waters, a female measuring just over 16 feet long, and used a dating technique borrowed from archaeology to estimate her age. The result was almost impossible to process. She was likely born sometime in the 1600s, meaning she was already alive when the Great Fire of London happened, before the United States existed, and she had been swimming in those same frigid waters, largely unchanged, the entire time since. The Greenland shark lives in the cold, deep waters of the North Atlantic and Arctic Ocean, growing at one of the slowest rates documented in any vertebrate on Earth, roughly 1 centimeter per year. That number alone hints at something unusual, because an animal growing that slowly and still reaching over 16 feet in length has to have been growing for an extraordinarily long time to get there. Confirming exactly how long required real scientific ingenuity, since sharks don't have the kind of bone growth rings researchers typically use to age other long-lived animals. A research team led by biologist Julius Nielsen turned instead to the shark's eyes, specifically the nucleus of the eye lens, a small structure made of proteins that form before birth and remain metabolically inert for the rest of the animal's life, essentially preserved in place, unchanged from the moment the shark was born. Using radiocarbon dating on that tissue, the same fundamental technique archaeologists use to date ancient artifacts, researchers could estimate almost exactly when each shark's eye lens, and therefore the shark itself, had originally formed. The results, published in the journal Science, estimated Greenland shark lifespans between roughly 270 and over 500 years, with the largest specimen in the study landing at a central estimate of around 390 years old. That makes the Greenland shark, by a wide margin, the longest-lived vertebrate confirmed by science, surpassing even bowhead whales, previously considered the longevity record holder among animals with a backbone. Here's the detail that makes this even stranger once you actually sit with the math. Because reaching sexual maturity for a Greenland shark takes an extraordinary amount of that lifespan on its own. Researchers estimate Greenland sharks don't reach sexual maturity until somewhere around 150 years of age, meaning an individual shark spends a century and a half simply growing before it's even capable of reproducing. A timeline so extended that a shark born the same year as a major historical event most people learned about in school could still be, by shark standards, not yet fully grown when that event became ancient history. Part of the explanation for this extreme longevity comes down to the shark's environment and physiology working together. Extremely cold water dramatically slows metabolic processes across almost every measurable biological function, and Greenland sharks have adapted a correspondingly slow, low-energy lifestyle, moving sluggishly, feeding opportunistically on whatever slow-moving or already dead prey becomes available rather than actively pursuing fast prey the way most predatory sharks do. That reduced pace of living appears to be directly connected to the reduced pace of aging the researchers have documented. There's an unusual physical detail that compounds the animal's overall strangeness. Many Greenland sharks are host to a specific parasitic copepod that attaches directly to their eyes, often affecting their vision significantly, and in some individuals causing near-total blindness in the affected eye. Because Greenland sharks rely so heavily on scavenging and ambushing slow prey rather than active, vision-dependent hunting, researchers believe many individuals function adequately despite carrying this parasite for essentially their entire multi-century lifespan. Even the shark's own flesh reflects its unusual cold water adaptation. Greenland shark tissue contains extremely high concentrations of a compound called trimethylamine oxide. Along with urea, both used to regulate the shark's internal chemistry in frigid, high-pressure water, but making the fresh meat genuinely toxic to humans if eaten without proper preparation. In Iceland, the meat is traditionally fermented and dried over several months, specifically to break down those compounds, producing a dish called hákarl that remains edible only because of that extended, deliberate processing. So somewhere in the deep, frigid waters of the North Atlantic right now, there may be a Greenland shark alive today that was already swimming in those same waters before large parts of recorded human history had even happened yet, moving slowly, aging almost imperceptibly, entirely unbothered by the astonishing amount of time it's already spent alive. If you found out an animal alive right now had been alive for 4 centuries, would that change how you thought about your own sense of time passing at all? Tell me honestly in the comments. And subscribe to NatureCrest for more deep dives into the animal kingdom's most extraordinary and most misunderstood creatures.